So really, each new version of Android, is getting more secure than the previous. But what this means is more restrictions for us developers and for those involved with Android apps. More things we need to be aware of, and that's really the goal of this talk. It's to get you up to speed on those new restrictions, and what you need to be aware of, what you need to change. And much of this talk is based off the SDK docs, the Google developer videos, and my own sort of research and experimentation with Android 15 beta. We'll also do a little bit of a recap of Android 14. Because a lot of us will start targeting that as a main version soon. Another key thing I wanted you all to take away is that when you need to be aware of this. Google spend a bunch of time and effort on maintaining backwards compatibility. For those Android developers in the room, we know that's all controlled by the target SDK version. And so each slide will have this kind of thing as a subheading, so when I'm talking about a particular restriction, whether this applies to all apps running on that version of Android, or whether it's just when you're targeting that version of Android. It's a great feature built into the system to allow us to do this. I know myself when back when runtime permissions came out, it was a big change. Scope storage was another one of those things, a big change, and it was great to be able to not target the latest and be able to sort of work on those changes and then deliver those once you've once it's ready. So this is a key part of it. We'll start off with the recap of Android 14, and these are just the highlights that I felt were worth reiterating. As we can see, we don't have for those who've been in Android a while, we don't have that lovely pie chart anymore. We have to go by the stats in Android Studio. But it's roughly about 13% for Android, for targeting 14. So it's not the majority, but as we'll see more and more, this will be our target version. And one of the key new things that came in Android 14 was this whole idea of a minimum installable target API. So this was similar, the Google Play Store has something similar to sort of force you to keep updating your apps. But now this is built into the OS, and the whole point behind this is, I kind of mentioned just a couple of slides ago, this is great, that we can not be have to adhere to the new restrictions because we haven't, the app's not ready yet, and we can control that with Target SDK. But what malware and spyware does is just target the older versions, and so you can sort of circumvent this. So this is now built into the OS to sort of force apps to be updated. We should note that if you're already installed and the device is upgraded to Android 14. You won't be uninstalled or anything, you'll still have those permissions. And then for us developers who use ADB, we can bypass this restriction. But the core takeaway here is that if you're not, you must target Android 6, when runtime permissions came in, otherwise you won't be installable on Android 14. So I think this is a good, a nice improvement. And spoiler alert, this is further bumped in Android 15, and I'm sure we'll see this continue in that moving sort of window of where you have to target to be installable. Another thing this is not a new thing, but that's been updated in, I think, probably for the last 5 years. The non-SDK interfaces have been updated, and for this is when you're accessing any hidden method or field within the SDK. Typically, you'd use reflection for that. And these are this is a blacklist and a grey list of APIs that are sort of will error and crash out if you try and access them. I think probably most of us in the room know if we're using reflection to access hidden stuff, we know it's quite risky. We know it's kind of likely to break. But I think what it kind of should bring home to you is that you don't necessarily know every line of code in your app. Third-party libraries might be making use of some non-SDK code, some hidden method. And so that's where testing for this can be super useful. If you're running running a debuggable app, you'll see that the warning for this in Logcat. You can also use the strict mode detect non-SDK API usage, which again is more of a manual thing. I don't know how you say this, Veridex. I just sort of discovered this. I'm probably butchering the name, but I discovered this static analysis tool during the research for this talk, and the link to it is there. And this could be really useful to run as part of a CI pipeline. So any new kind of libraries that you introduced, you could run that tool, and it will detect if there's any sort of new, not vulnerabilities, but new usages that could be a problem for you. It's not as fully featured. It doesn't sort of go. I think it doesn't detect like reflection code like in JNI code. But yeah, it's not as sort of as fully featured as say like the strict mode, but could be I think it's a useful tool to add to your like CI pipeline, like I say. And if you distribute via the Google Play Store, that will also, as part of their like testing, they'll flag up if there's any sort of code using this. So yeah, not much probably that for our own code that we need to change. It's more like third-party code and adding sort of testing to make sure that our app isn't sort of susceptible to that. And yeah, another sort of spoiler alert, this is, in 15, this is bumped as well, and it's a pretty much copy and paste to the slide. And I'm sure we'll see that in every new version of Android, this sort of reducing down of what we can access. There was also a bunch of restrictions around implicit intents. Now, the tooling's really good at flagging this, but implicit intents, they'll only be delivered to exported components. And the key thing here, this is also for internal components. So if you're sending a message to a different part of your app using intent, you need to make that explicit. So you can't just do that. You can't just send an action. You need to give it. For this, you could just solve this by adding the package, effectively turning this from an implicit to an explicit intent, and that works. There is also changes around, if anyone remembers from Android 13, when you started targeting that, your manifest file was full of red, where you had to explicitly say whether your activities or any of your components were exported or not. Now in Android 14, when you're targeting it, if you're registering a runtime receiver, you also have to do the same thing. The exception being if it's a system broadcast, you don't need that flag. It's just a same method call, but like it's an overrided call. It's worth noting. You'll get an error if you just, or rather, you won't get an error. If you register it, it won't receive those messages. And the last two things are sort of more like vulnerability mitigations, and it's very like niche if you're using that. If you're using dynamic code loading, the files that you download need to be marked as read-only, otherwise they won't run. So this is like, you do this in the Java I/O or Kotlin I/O when you're physically saving this to disk. And the recommendation is that if you've already got files that you're using for this, you should delete them and re-download them to ensure they're read-only. Again, that's it's quite niche. If you're not using dynamic code loading, then hey, no need to worry about it. Similar with if you're using zip files, there is to sort of try and prevent path traversal vulnerability. If you have names with a dot or start with slash, they'll cause a zip exception. So you can sort of that may be valid for your use case, so you can opt out of that. But that's something to sort of bear in mind if you're using zip files. You start targeting Android 14, you might find you're getting exceptions. So what's new in Android 15 apart from the logo and this T-shirt? As I said earlier, like the spoiler was that we have a new minimal installation target API. And this is bumped up now to Android 7, Android Nougat, which brought us, for those who remember, like secure networking. Now you couldn't have, previously you could have a user installed certificate which all apps would trust. So it was great if you were doing SSL proxying against your app or man-in-the-middle attack. You can't do that anymore from Android 7. And now to be installable on Android 15, you need to target Android 7 and above. Yeah, it's a great, good improvement to Android, and yeah, and so that's, again, if you're already installed, you're not going to be, you're okay, and you can bypass this locally if you need to test. As I said, the non-SDK interfaces restrictions also was bumped. I'm not going to sort of repeat myself here. It's literally just the same thing, and the same. The key takeaway, like I say, is that it's like static analysis tool or some sort of automated process where you can validate your app's dependencies for this type of thing. Private space is probably the biggest sort of security or privacy feature that we've seen in Android for a little while. Very much like a user-facing thing. So it's a way of hiding or segregating apps that are installed to this space. It's hard to see on the slides, but there is a sort of a slightly different area in the app drawer for this private space, and it works. And the new icon is a key thing. So you'll see that like the what's new, the sort of default Android icon there. You can see is an app I developed as part of this talk just for testing, and you can see it's quite totally legit to install that to both your regular app install and private space, and you can see that it's delineated with this little icon. So what is it like? It's similar to Work Profile if anyone's used that. It's essentially the private space is a different Linux user, and so that's the way that segregation works. I forgot to mention also that this is very similar to Samsung's Secure Folder, which has been around for a little while, but I think a different implementation. But this is now obviously in the main OS. It's only supported for the main user, so if you're a secondary guest user or a managed user, like as if you were in Work Profile, you can't go and create a private space. You can use a different PIN code or the same PIN code, but crucially, you can't move apps. There's no concept of that. It's a completely segregated sort of space. So when you see the install button here, that launches the Google Play Store to install it it's a separate install. Even if you have that app already installed, you can't. I say there's no way of like moving it. And that's something I kind of missed when Google first announced it. There's no sort of like moving between them. If you want to install to it like just without the Play Store, that's what I was going to say. You don't have to use a Google account, like a separate Google account for that private space, but it kind of defeats the object, I think, to having a segregation of accounts if you've got your same Google account logged into your main device as well as private space. For us developers, when we're testing if our apps work in private space, we can. It's very easy to do. We just need to get the user ID effectively of the private space. In this case, for me, it was user 10. So you use that shell dumpsys command, and then you can use ADB to install using the user flag. This is a credit to Rene for this. His blog. These are sort of pulled effectively straight from his blog. Good post. You can also, in Android Studio, use the install to all users, and you can also, alternatively, the install flags. You can see that same user 10. So that's useful. Although I found during my testing, this didn't work every time. It was a bit flaky. Like I would be making some changes, deploying it, and then the app installed into the main area was updated, but the private space wasn't. And I don't know if that was to do with Canary version of Android Studio, beta version of Android 15. But just be warned, it's not necessarily works every time. So what are the restrictions around private space? So always, for all apps, you can't receive Bluetooth content. You can send Bluetooth content, but you can't receive it. You also you can't add widgets or shortcuts. So this is if you're installed into private space. So if you're a widget only app, then this isn't this area isn't for you. And when you're sharing content, if you're using like the photo picker that Google have sort of backported, I think to Android 11, if private space is unlocked, you have there's two tabs, and you can sort of share directly to private space apps, but only when it's unlocked. And the other thing as well is that it bypasses VPNs, which made me sort of like pause a bit, because I was like, a recent app I'd worked on communicated exclusively via VPN, so I wanted to sort of run into this in more detail. So I just thought to do a little demo of this, and so I connected my VPN via private internet access. Other VPN providers are available. And we can see this connects okay. I was connecting in Bristol, my home, and everything's all good, it's connected. But when I went ahead and launched Chrome in private space, as you can see denoted by the little private space icon, it wasn't connected and it just went directly to the internet. And that's something that I don't think is, hasn't been very well highlighted in my opinion. And it's only through digging through the documentation that I realised that. So yeah, that's something to bear in mind if your app requires that kind of connection. But I think it will, I think for users as well, I think this isn't necessarily clear. But of course, if you then go and install your VPN into private space, connect it up, then it works as intended. I think that's the segregation way. It's completely separate. And I just thought it'd be useful to show this is that the same app running the same notification effectively, and the only difference is that little icon that you can barely see, just to denote that that's a private space notification. And so if your app has some bespoke logic that identifies the device by the device ID or something, then you can only have one instance of that. That might be an issue for you because you can run multiple instances of apps, and like this as an example. I think one of the key areas where to consider with private space is when private space is locked. And in this sort of scenario, I wrote it up as a kind of acceptance criteria just because that was the mindset I was in at the time. But the app is completely stopped. So, you can't have any foreground services running, you can't have any background activity launches, you can't show any notifications, you can't access sensors. So this is really an issue for, say, a medical app that connects to a blood glucose monitor. That's not going to work if that app is installed into private space. And Google will mention in the docs, this isn't suitable for medical apps, but I'm sure there's many other sort of use cases which aren't supported. My issue with this, or the concern, is that it's kind of left to us, developers and people involved with apps, to sort of inform our users. It kind of sort of says, just inform your users not to install it to private space. And it's kind of like, is that it? There's no opt-out. We can't. If we had a widget app, or if I've got a blood glucose monitor app, I can't opt out of private space. I can't say, it'd be nice if there was a manifest flag or something to say, hey, this isn't suitable, and don't install it. But I could just see this leading to a lot of one-star reviews when people have missed notifications, not had their data synced or whatever because they've installed their app to private space and it doesn't work as they expect to. So that's something that we, developers have to sort of manage that expectation. And I think that's where I struggle with that. I think there needs to be more done from, the platform side or something to sort of help with that. One thing you could do, and this is, presentation code, so use it with a very large pinch of salt. But you could detect if you're running in private space. And there's no official kind of API for this, but the user manager effectively gives you this. You can check if you're the system user, which is like the main user. And then you can also check if you're not that, then maybe you're a managed profile, i.e. work profile. And if you're not that, you could be in the user private space. So you could use something like this to detect whether it's a good case you're in private space and maybe pop up some sort of disclaimer or notification or prevent certain functionality working. Because if your app needs to do something important that won't work in private space, that's all we can do. I think maybe we'll see something more better, for a lack of a better expression, from Google to sort of allow us developers and app owners to sort of control this. But private space, I think it's a cool feature, but for a few of us, it'll be there may be some one-star reviews there because stuff isn't reacting as we want. I'm going to move on to a couple more sort of new features or new restrictions in Android 15. So this is kind of the reason it's a tap is that tap jacking is a vulnerability that we see that we've seen in Android. A lot of it was kind of closed down in Android 10 with the restrictions around background activity launches. But one of the sort of vulnerabilities or ways around this was if you were in the same task, you could sort of get around that. And when we're talking about tap jacking, we're talking about like pop-up ads that effectively block the full screen and like force you to watch it, where you put full or partial tap jacking where you're intercepting taps to the screen, and then also like modals where you're like phishing an existing app that's there. So the idea is that's just like tap jacking in general, but the idea of task jacking was you could circumvent some of those protections if you were in the same task as the target app. The new sort of mitigation for this is quite simple to implement. It's just like one field in your Android manifest file. So you could turn that on, disable it, allow cross UI activity switch from below. You could disable that on your whole app, and then you would enable it on activities that you specifically want to share content. So I think this is a nice change, and I think a no-brainer for most apps that care about sort of security. One sort of not caveat but warning that this is only when you're targeting Android 15, and the app also at the top of the stack must also target Android 15 for this sort of protection to work. So it's not like a silver bullet. It's going to take a little while before more apps are doing that, but I don't see a reason why you wouldn't sort of put this in place. I mentioned a little while ago about intents in Android 14 being sort of further restricted, and we see some more additions to this in Android 15. It's now around sort of matching the intent. So like now intents must have actions. And I just want to draw attention to, this is when you're targeting Android 15, but it's not enforced. And this was kind of like a new one for me. Like when I was trying to code up an example of this to illustrate, it worked. And I was like, what am I doing wrong here? And it was only through like one of the comments in one of the Google I/O videos did they mention, oh yeah, this is not enforced yet, so we can all kind of get used to this new restriction. So when you're calling from an external app, this first intent, at the moment that works, but when you're targeting Android 15, like I say, it works at the moment. When that will change, I don't know, but this is like an unsafe intent launch, and so because it hasn't got an action, so that the addition of that public action there will keep you keep you compliant effectively. So if you're calling through to other apps without an action, you need to go and find that. I'm sure that's the kind of thing that the Android tooling will flag up to us in Android Studio quite easily. The other thing is that when you're targeting an intent filter, it must match it. So this is a similar example where we have a private action, but if you see it's being sent to a public receiver. And so the pattern or the vulnerable pattern that Google have kind of like flagged is that if you have something like this in your code, so this is a public receiver, and legit to want to extract the logic of that out to something else, like we want to keep our Android components as dumb as possible, so we can pull it into sort of JVM and we can unit test it. So having a broadcast handler to sort of handle that intent and do something, that's legit. The issue comes with this, the handler implementation, where it's just like going on the action and then executing the sort of whatever private function based on that. So you can see I'm sending a private action to a public receiver, but this code is then accidentally, it's passing that on to the private thing. So the idea is that Android 15, once this stops being, once it's enforced, I should say, this won't happen because the intent won't be sent through to the broadcast receiver. You might be thinking, well, that's not an issue for me because I always code defensively. This is one of like a receiver I would write. Be a bit more defensive. The validation of the action takes place in the receiver. So if it's not right, if it's not the correct action, it will just log it. This is literally cut and paste from a project I've previously written. So if you've done this, then you don't really need to change anything. But from Android 15 going forward, you won't need this kind of validation because the intent won't ever reach your receiver if it's the action's wrong or the MIME type's wrong or anything like that. So I think it's a nice improvement. But yeah, it's not enforced yet. But how do you know? How do you know if your intents are unsafe or not? And that's where we have a new strict mode that you can put in. This is the only place, like if you run through the sort of samples that I showed, and with the strict mode enabled, you'll see a little thing in the log cat to say that's unsafe, and that's even though it's still delivered at the moment. Yeah. So that's those a couple of things around safer intents. There's been a couple of there's probably if you use foreground services, you probably not surprised that there's further restrictions. It seems to have been the target, just like permissions and storage has been for the past couple of years. Now we need a new foreground service type, which has a bunch of extra validation and a bunch of approvals for the Google Play Store. So we're seeing, and now in Android 15, there's also timeouts around for certain types. So data sync can only run for like 6 hours. There's further restrictions. So the ones that I picked out were like, if you have a boot completed receiver, so this is where this is triggered when the device is fully booted. If you are trying to launch one of these foreground service types, you're out of luck. From now on, you're going to start getting a foreground service not started, not allowed exception. And this is all around the sort of push back on us all to make sure the user has launched our app before we start doing this, any kind of background services or foreground services, which is a shame, I think, for some apps that want to sort of synchronize data or do stuff to make so the data is all fresh for when the user launches the app. We're not going to have that same facility. Similarly, if for background service launches, if you have been lucky enough to be able to get the system alert window, which is not which is a fairly non-trivial permission to request for users. It used to be a bit of a get out of jail free card. Like you didn't have to sort of pay attention to all these new restrictions. Well, that's changed now in Android 15. Your app needs to be visible as well as having this permission. So you can get that from the view, get window visibility, or you can add a listener to the on window visibility changed. But essentially, if you don't have that and you try and start your foreground service, you're going to get that lovely long exception. That's something worth, fairly niche unless you're working with foreground services and the sort of pain that comes. But some more restrictions and more ways that I think it'll kind of come to you. Like you just can't do certain stuff until the user's launched your app, and that's just going to be the way. Or unless your app, in this case, unless your app is actually visible. Cool. Brilliant. The last sort of area I just wanted to cover was the privacy sandbox, and this it's not released yet. It's sort of built into Android. It has been for a couple of versions, but it just highlighted me it's an interesting initiative from Google to sort of try and keep ad-based apps and games viable. But also protect sort of user privacy. So it's really focused at web and Android. I mean, it kind of makes sense, right? They can't influence sort of Apple and iOS. But it's like an alternative to sort of cookies and advertising. If you go to the Privacy Sandbox website, they talk about some stats around 90% of apps in Google Play are ad-supported or free. But people are concerned with app tracking. Like you search for something like a dishwasher in one app, and then you get a bunch of dishwasher ads in another app. It feels creepy. None of us like that. So the idea is to try and let's still allow ads, but I'll give the users more control so they can turn off certain elements of that. And so that's what this is. So taking a step back, when we normally put an SDK, any SDK, open source or commercial, into our app, via Gradle dependency, the SDK is part of our code. It's separate because it's a separate dependency. We didn't write that, but it has access to our process, our memory, and crucially our permissions. So if I had a running app which I allowed access to location, background location, pretty like fundamental thing for an app to track your running. If that app also had ads, you're also sharing it with the advertisers, and that's the sort of scenario we have at the moment. It's not ideal, and the idea of Privacy Sandbox is that it's like a decoupled, like a segregated area where you still put the dependency, but your dependency would be like effectively just interfaces or a stub, and the SDKs would be likely via the new Google Play SDK console. So if this is like more the bigger changes here is if you're an ad SDK developer. But the key thing for us, in our apps that use those, is that we would still functionality would pretty much be as is. It's just that the implementation and the code would run within this Privacy Sandbox. And the key thing is that it's a separate permissions, separate process, separate memory, and so and the user can control that. So in the running app example, your app could happily have location permission, but as a user, I could deny the location permission to the ad SDK. I think that's a win for privacy, and it sounds quite interesting. It's not ready yet. Like if you want to enable it on your Android 15 device, you have to run a couple of ADB commands, and you can get something like this to come up. This is like the settings screen that you'd see, and you can see your ad topics and things like that, and then edit them. This is all like the kind of thing that users would have access to once this feature becomes production ready, I guess. And the sort of new stuff is like the core APIs, topics, Fledge remarketing, and then the measuring of ads have all been sort of updated. And you might be like, why sort of mention it? Because the key changes there, or the key information, really is for ad SDK developers, and maybe there's a couple in the room, but probably mostly not. But it really sort of hit home that whole any library, commercial or open source, closed or open source that we include in our projects has access to all our stuff. We know that in the Google Play Store, the data safety information is like front and center, like what information our apps are accessing, and so it's just really crucial that we all like bear that in mind. Any dependency we put in, that we understand, what it's doing, what it's accessing, because, if you don't know that, if you don't know line by line, which is unrealistic, I think, in real terms, like what apps can do, like what SDKs and what they can do, they can run as you, and you're responsible for that. You're responsible for your customers' data, and that's what it kind of brought to mind. So I quite like this idea that Google had done, this segregated sort of area and separate permissions, and it'd be interesting to see what other whether there's other sort of libraries or other sort of niches that can come into that. So I think that pretty much almost done. The key takeaways for today, hopefully that is the image of takeaways for people in the room, is for me. So if you're running on Android 15, targeting Android 15, you're going to need to target Android 7 or above, otherwise you can't be installed. So this is, like I said, this is great to stop those sort of old apps which have been they've been circumventing all these new restrictions, spyware type things, and if just so you will need to do that, otherwise you won't be installable on Android 15. Look at automating the checking for non-SDK interfaces. There's a bunch of options where you can flag them up. But I think that static analysis tool sounds really promising, and it's the kind of thing that once it's set up, you sort of don't need to think about until new versions of Android, and there's any problems that come up with it flags. Private space, we spent most of the time when we're talking about Android 15 talking about that. It allows users to install another instance of your app on the same device. For certain apps that's going to be an issue. It's not suitable for anything that needs to run in the background, because as soon as private space is locked, the app is going to be shut down and closed. And crucially, you can't opt out, and you're going to think about how to manage that. So I guess that's one of the key takeaways. The code that I put up around like detecting that may be something that is useful. And we saw both in Android 14 and in 15 that intents. There's a bunch of small but restrictions around intents. So in general, prefer to being more explicit than implicit. But yeah, that's it. Thank you very much for listening. I hope you found this useful. I'll be around the rest of the conference. Come and say hi. If you have questions or feedback, I'll take them outside. That sounds a bit weird. But yeah, I'll be around. I'll hang around outside for the next 20 minutes, half an hour. And yeah, enjoy the rest of your day. Thank you very much.